supposed to be parentheses there.
Today you're gonna learn, actually you're gonna review inverses, because we've already done inverses last year, so we're gonna go rather quickly. So let's start off quickly. Do you guys even remember what an inverse is?
Kind of.
What do you mean by flip?
Like the X and Y. Like,
The X and Y switch spots.
Yeah.
See, you're telling me it's review.
Yes.
So all we're gonna do is just go back in time and talk about what this stuff is. So if I were to ask you what the domain of this function is, what would you tell me? And how do you even know it's a function?
Is your domain
because the
repeat?
X values are repeated.
Does the domain repeat?
No.
No.
No. What is the domain?
Your x values and your
Okay.
coordinates.
6.
2, 4, 6, 8, 12, right? What's the range?
5, 7.
3, 5, 7, 20.
Do you repeat 7?
Yeah.
No.
5, 7.
Never repeat and put them in order from least to greatest.
Is there supposed to be a parenthesis after that 20 or no?
After the 20, which 20?
No.
Oh, yeah, right here. Yeah, that was a typo, my bad. Okay, so now, let's talk about, now that we remember what domain and range is, here's another relation. What state the domain? 0, 2, 4, and 8. What's the range? 1 and 3. The inverse is what? What are you going to do now? You're going to switch your domain and your range. So now, see this is going to be your 1 and 3, and your range is going to be 0, 2, 4, and 8. Easy stuff?
Yep.
Easy.
Easy peasy.
Okay, so if I were to ask you, could you graph an inverse, a relation and its inverse? Can you do that? Yeah.
Yeah.
How do you plot 0, negative 5?
Go down 5.
1, negative 4, 2, negative 3, and 3, negative 3. Now, if this has, if they're just, huh?
You have 2 y values of negative 3.
Sorry, 0, negative 5, 1, negative 4,
2, negative 3, 3,
2, negative 3, and, I'm sorry, this is, thank you, thank you. This is a function, right? It passes the vertical line test, right? Now, what's the inverse of this? Well, you're gonna flip this point, so we have negative 5, 0. We're gonna plot negative 4, 1. We're gonna plot negative 3, 2. And we're gonna plot negative 3, 3. Now,
You flipped it over the origin.
is the inverse a function? No, it is not. It does not pass the vertical line test. This is a function. This is a function.
Oh, we did kind of do this last year, didn't we?
We did.
I like
This is
parabola
not a
and stuff.
function. Do you remember? I'm gonna jump to a test. It's not called the vertical line test since everything is different. Instead of the vertical line test, what do?
Horizontal
You do a horizontal line test on the original
function.
problem. And if you were to draw a horizontal line through this, you would see that it would not pass, right?
So you can
It's
tell
hitting
already
in
that
2
it wouldn't.
spots. So that's going to give you an indication that the inverse sometimes will not end up being a function. It's just going to be, it's just an inverse relation, okay? Next. Can everybody recall taking a rule and writing the inverse of the rule? Okay, first of all, what does this look like if you were to graph it?
You move up a and then you're
Okay.
Slope is up to.
And there is, by the way, at the bottom, where problem number 3 is, there's a table, there's a graph that I want you to graph it. How do you graph y equals 2x plus 8?
So that 8.
And by the way, this scale goes up by 2 and over by 2. So up 2 over 1 looks like that. You gotta be careful on this one, unfortunately. You know what I'm saying?
Yep.
2, 1.
Oh,
Got it.
So, if you were to connect the dots, here is the graph of f of x equals 2x plus 8. Now, is this a function? Is it a function?
Yes.
Yes, it passes the vertical line test.
Don't all linear.
When I do, most of them, when I do the horizontal line test, does it hit in only one spot?
Yeah.
Yes, so when I flip this, when I do the inverse of this relation, its inverse will, I'm predicting it will be a function because it passes the horizontal line test. Now, do you recall how to come up with the inverse relation, the equation, the rule? Remember what to do? Switch the x and the y values. So this is going to be what? X is equal to 2y plus 8. Now what do? Do you leave it like that? We always get y by itself. Now I like to rewrite this, so my y value's on the left. You don't have to do that. I just like it because when it's done, y is on the left. How do I solve this for y? So I do subtract 8. Then what? Divide everything by 2 and clean it up. Now, is this a function? How do you graph y equals 1/2 x minus 4? How do you graph that?
Go down 4. Up 1 over 2.
Now, it's up 1 over 2.
So it's like a half over 1
Half, yeah,
over 1.
yeah. Because these are all by 2, so split them in half.
Can you go back up real quick?
Yeah. Yeah, let me finish my half, half. Here is the graph of it.
No.
Okay, go where? Up here?
Yeah. Okay. And then you try to find the copy. Okay, never mind.
Okay, so the inverse of a relation is when you're going to switch your x and your y around and resolve it for y. Now, we predicted, we looked at the original function. It was a function. This was it right here. And it does pass the horizontal line test. So this relation right here is the inverse of that. So how are we going to write this, that it's an inverse? You're going to write f -1 of x. Now, can I use this fancy notation?
Yeah, because it is a function.
Because it is a function. Now, do you see something symmetrical to this?
It's flipped over the origin.
It splits over, not the origin. Remember, origin symmetry is if 2 is on the graph, then -1, -2 is. That's not what's happening here. This has symmetry to the line y equals x. It's a reflection over that line. So if you were to fold this graph over the line y equals x, you would see that these two land on each other. And that's what this says, y equals x is your line of symmetry. So the graph of the function of f, it's a reflection over the line y equals x. Do you remember this?
Yeah.
Okay, now, let's go back here for a second. What is the domain of your function, f of x? Your domain is all real numbers. What's your range? All real numbers. When you do the inverse, These are gonna switch. Your domain is the range, it's this right here. It's gonna become all real numbers. And your range is gonna be this domain, all real numbers. They switch. Now, this isn't very exciting because all real numbers is all real numbers, all real numbers is all real numbers. Where it's gonna start to change is when you start working with parabolas and radicals. That's where you're gonna see a difference. And you're gonna have to talk about the domain and the range, okay? Now, let's just work on a couple more, practice a couple more different looking equations. This one says g of x is equal to 4 over x plus 2. How do you write the inverse of this? See if you know how to do this one. How do you write the inverse? What should I first do?
X equals 4 over y plus 2.
X equals 4 over y plus 2. Now, would you know how to resolve this for y?
Multiply by y, or multiply by 2, and then
How about if I put a 1 under here, can you guys cross multiply? What's 4 times 1? 4. Now, I'm trying to solve for y, so don't distribute that x. What-
divide.
You got it. Divide by x. Divide by x. And then what? Subtract 2.
Is it just next to the fraction, or is it on top of it?
Mhm. Nope, 4 over x minus 2.
Okay.
Now, do you recall what this thing looks like? You don't remember doing this last year? One of these? That's the reciprocal function. Does this pass the horizontal line test?
Yes.
Yes, its inverse will be a function. So you're gonna write this as g negative 1 of x. Try another one, just real quick. How do you find the inverse of this? See if you remember, tell me what to do.
You can rename your f of x as 1.
Okay?
Then you flip your y, your x.
Mm-hmm.
Then you add 2 and divide by
Add 2
equals 1.
and divide by 2.
Yeah. So x equals
So y is 1/2 x plus 1. Oh, this is 3y, you guys, I'm sorry.
Oh.
3y, add 2, divide by 3,
so 1/3.
1/3 plus 2/3. Sorry, guys. Thank you. Okay. Now, we talked about this, one-to-one stuff. If it passes the horizontal line test, if a function is 1-to-1, it will pass the horizontal line test. And that's gonna be an indication to you that its inverse will be a function. So I want you to flip to the back. If I asked you to use the horizontal line test on these 3 graphs, if you were to graph, hi. Okay, this graph is right here, okay? And B is right here, and C is right here. It's already graphed for you on the calculator. So this A is right here. Does this pass the horizontal line test? If you were to draw a horizontal line through here, does it only hit in one spot? Yes. So that's an indication that when I do the inverse of this, it will be a function. So this is 1-to-1. This one is or is not? Why?
This is past the horizontal line.
Because if I draw a horizontal line here, it's not gonna, it's hitting in more than one spot. So this one is not 1 to 1. The inverse, when I do, even though this is a function the way it is right now, when I invert it, when I do the inverse of it, which means switch x and y around, I'm gonna predict that its inverse is not gonna be a function. So I can't call this, when I do the inverse of this one, I can't use that notation. Not able to do that. Just like you can't call me Dr. Audia, because I didn't go through all the schooling. You can't call this g negative 1 of x when you flip it, because it's not a function. And the last one, is this one gonna be 1 to 1?
Yes.
Yes,
Yes.
because it passes the horizontal line test.
What about in the middle, that straight line?
It's not, it curves, it's like this.
Oh,
Are you sure?
okay.
I'm positive. This is a cubic function. Yeah, it's because the technology makes it look like that's flat. It's not flat. Yeah, that's not flat. That is deceiving. It's not flat. Okay, now, this part you're not gonna like. 2 parts, the restricting the domain and verifying that an inverse is a function. So, let's do this verifying the inverse is a function. If I gave you this function right here, f of x is equal to 5 over 2x minus 4, and I asked you to find the inverse of this, what would you do? What would you do? This, you would switch your x and your y around and resolve it. And you'll get this. And if I gave you that problem and said find the inverse, you would get this. So there's another way you can prove that this is an inverse of that. What you're going to do is do the composition of functions, f of g of x.
So we're plugging that in the other one.
Oh my gosh.
Oh my gosh.
So plug x in for g. And
You're
take
gonna
that
plug
function
g
and
in for x, and what you're gonna end up getting is x. Yeah, and I'm gonna show you right now. And then you're gonna do g of f of x, and you're gonna get x. Watch how amazing this is. You're gonna be amazed. Okay, so, how do you do f of g of x? What do you do? This is fun. This is fun.
So, you take your g.
Take g of x and plug it in where?
For your x.
For your x. So Nick, what do I write?
5 over 2, and then parenthesis 4x plus 5 over 2x. Parenthesis minus 4.
Good job. Good job.
Cry.
Now,
Think about your life choices.
okay, can anyone remember what to do with these 2's mathematically? They cancel. So you have 5 over 4x plus 5 over x minus 4.
Oh, now it's one of those fractions.
Oh, it's one of these problems. What do you do now?
Flip it
I'm giving you a hint.
Oh, okay, so solve that first. Yup.
Right?
Yup.
Okay, then what? What? Common denominator. Then what? You do 4x plus 5 minus 4x. What's 5?
5.
Oh, how'd you get that?
Just they cancel out.
These 2 cancel out. So you have 5 over what? 5 over x.
So now you flip and multiply.
Thank you, Nick. 5 over 1. You're going to flip. What happens to these 5s?
Oh yeah, they're gonna cancel.
And what did you
You
get?
got x.
We got x. And you guys did that.
You
Nick did that,
No,
actually.
she did that.
She did that.
Okay, now let's see if we can do the other one. Now I'm telling you, it is going to equal x. It is. You just have to show the guts of the problem. Alright, so now,
Everyone equal X?
if they're inverses of each other, yes, the composition of them will result in an X. So now let's prove this one. How do you do G of f of X? What are you gonna do right now?
You plug in the F.
What do you plug in? This is gonna go in for X now, here and here. So you have 4 times what?
Yeah, minus,
Plus 5
over 2,
over 2
5.
times 5 over 2x minus 4, right?
Yup.
Okay, now let's see how
Do those
sharp.
cancel out right away?
Huh?
Do those cancel out?
Not right away. No, not right away. How do you multiply 2 fractions? How do you multiply 2 fractions? Abby, how do you multiply these 2 fractions? How do you multiply
I
them?
think you know this one, dude.
Come on, tell me. No, not reciprocal, we're not dividing. How do you multiply 2 fractions?
Cross multiply.
Okay, so what's 4 times 5? 20 over 2x minus 4 plus 5 over 1. And now how do you multiply these two, Abby? No, we just did it right here. 4 times 5 is 20. What do you do here? Yes, 2 times 10. 2 times 5 is 10. Now we go back. How do you combine these 2 fractions? What do we need?
Common denominator.
So you're going to multiply this by 2x minus 4 and this by 2x minus 4.
True.
Right?
True.
So what do you get here?
10x minus 20.
10x minus 20, so you have 20 right here, already there. 20 plus 10x minus 20 over 2x minus 4 over 10 over 2x minus 4. This is called a complex fraction.
Yeah.
You did these in algebra 2.
Yeah.
Okay,
It's
next,
that.
clean this up, clean the mess up. What do you have?
Okay.
Someone sees something.
Those two.
Before you flip
Did
anything,
2x minus 4s get rid of each other now?
they will,
What I
yeah.
just said.
These two will cancel.
No one was more.
What else?
So then you got 20 plus 10.
20 minus 20 is
0.
0. So what's
1
left?
x. It's an x.
10x over 10.
It's an x.
Cross out the 10s. What's left?
X.
X.
That was worse
We should say it X.
I know. Because we know it's gonna come out to x when we just say.
Yeah, that's what I was thinking.
I was gonna write that on my
Do we just write X?
No, you have to show, this is like in geometry. You know how you had a proof?
We're getting
I
remember
don't
that.
answer those questions. I live proofs and
We have math together.
Okay, now one more thing we need to talk about. Restricting the domain, and we did this a lot last year. A lot. If I give you this problem, can you tell me what this is? What does it look like? A quadratic.
No, that's not what I meant.
A rocket. Where is it?
It's shifted to
Is it here?
X to the
Is
right.
it here?
On the X axis.
Moving to the right.
Right there, yep. Then you're gonna, perfect.
Right?
Curve.
Now, could you give me some points, some good points? What point is this?
That's 0.
Okay, can you give me another one? 3, 1,
4.
6, 2.
6,
No, wait. Right?
2,
Yeah, that's
3, 4,
Oh my God.
5, 6, 2. Okay? So, can you tell me what the domain and the range is of this? This is important, guys. Please pay attention. What is the domain? You took a test on this stuff last month. What's the domain? Can I use 1 as a domain for this?
No.
No.
correct.
The domain is x is greater than or equal to 2. Why? And the range is y is greater than or equal to 0, right? Now watch this. When I do the inverse of this, this is the function f of x is equal to the square root of x minus 2. If I were to do the table, what does it look like? And I'm going to do it in red. 0, 2. Where's 0, 2? Right there. How about 3, 1? Over 1 up 3. And how about 2, 6? Somewhere here, so it looks like this. Do you agree that this is the function and this is its inverse?
Yes.
Is this a function right here? The original.
Yeah.
So we're going to call this the original f of x.
So f minus
Is
1.
this a function?
Yes.
Yeah. How do you know it's a function?
Because the first function passed the horizontal line to
Okay. Now, I want to look at the rule. Let's compare the rule of this. How did I tell you to take this and write the rule? So it's y equals the square root of x minus 2. What do you do when you do the rule?
So x
You
equals
switch x
square root.
and y.
So you're gonna square both sides.
You're going to square both sides. Why are you going to square both sides,
Because you want
Nick?
to get rid of that radical.
You want to get rid of the
And then you're
radical.
gonna
Then
add
what?
2.
Add 2. So y is equal to x squared plus 2. But guess what? That's a parabola,
Yeah, it is.
isn't
But
it?
part of it's extraneous.
So it isn't.
Isn't it? The other
So
half.
this
Oh.
is really the graph of y equals x squared plus 2. But that's not the inverse of this. Only this red part is. So what do I need to do? This is the important part.
You need to justify the domain.
Yes, you need, this is what we call restricting the domain. You're going to switch these two. Not only do you have to switch the ordered pairs,
But you have
and you have to switch the equation, but there's times when this like grew a limb. And that's not what it is. It's not both of them, it's one of them. So what are you going to do here? If you write that the domain is the x values greater than or equal to 0, and the range is the y values greater than or equal to 2, what you are doing is stopping this from happening. You're saying my domain for this inverse is only the x values that are greater than or equal to 0, which is this. You're not going to allow yourself to use that. Even though the equation states this, when you restrict the domain,
That's what
you're
doing.
stopping from using that. Does that make sense?
Yeah.
Okay. That's very important. You have to restrict the domain. Okay, here's your homework.